Aristotle theorizes that running vertical force-time waveforms consist of two components, each corresponding to the motion of a portion of the body's mass. A smaller component corresponds to the impact of the lower limb with the running surface, as represented by the impulse 1 curve in red. A larger component corresponds to the accelerations of the remainder of the body's mass, as represented by the impulse 2 curve in green. The total vertical force-time waveform is a sum of these two components, as represented by the blue curve.
So we divide this up into contact, which may or may not be at the heel, it might be further forward, and then we talk about mid-stance or foot flat, and then we go into propulsion phase of gait. Each one of these separate phases has a specific purpose. So the purpose of contact is the shock attenuating phase. We know that when you run, you've got about 3 times your body weight going through your system. So you imagine standing, 2 guys my size on my shoulders, and then going up onto your big toe. That's exactly what happens when you run. So it's very, very important that we have shock attenuation at that time. The other thing that happens at contact is that we need the foot to adapt to any unevenness in the terrain. So you can think about rocks, any sort of obstacle that might vary the terrain. The foot needs to recognize that. So at contact, what happens is the knee flexes and the foot pronates. Just like a car's shock absorbers, very, very normal, very, very important. The foot continues to pronate to mid-stance or foot flat, and then it must remain very, very stable. Mid-stance is about 50% of the whole time your foot is on the ground. So mid-stance is the stability phase of the gait cycle. We then go from mid-stance into the propulsive phase of gait. Propulsion is signaled by the instant the heel leaves the ground. As soon as the heel leaves the ground, you are in propulsion. The propulsion phase is when the foot starts to resupinate, so moving back in this direction, and when the foot resupinates, all the bones pack closely together and the foot becomes very, very rigid. Now you can imagine the purpose of that. The purpose is to make sure you've got a nice rigid lever so you can get effective propulsion, nice force generation as you move forward into the next stance phase of gait.
This video illustrates one of the most used parts of the human body, the knee. One can understand the intricacies of the movements of the knee by getting familiar with the joints and the bones which form the region of the knee, and the set of complex muscles which make it so easy for humans to move their legs. The knee is one of the most important joints of our body. The knee is essential in moving the human body and also in running, walking, and jumping. The knee is a joint which is the central part of the leg, where the thigh and the lower leg join. The knee is considered to be the largest joint in the human body, with a very limited region that encloses and supports the joint, which makes it even more complicated. The knee is a mobile trochoginglimus, which is a pivotal hinge joint. The trochoginglimus permits flexion and extension, as well as a slight medial and lateral rotation. In humans, the knee supports nearly the whole weight of the human body, so the joint is vulnerable to both acute injury and the development of osteoarthritis. The knee consists of 2 crucial bones in the knee region, which include the femur or the thigh bone and tibia, also known as the shin bone. The knee is protected by the patella, also known as the kneecap. The knee joint has a cushioning support that is provided by the articular cartilage. The articular cartilage protects the ends of the thigh bone, shin bone, and the kneecap. They mitigate the direct stress on the knee joint and also act like shock absorbers between the bones and the knee. The joint is present in synovial fluid, which is inside the synovial membrane, which is called the joint capsule. The ligaments present in the knee stabilize the rotational movements of the knee, including the forward, backward, and sideways motion. However, collateral ligaments running along the sides of the knee restrict certain angular movements along the sideways of the knee. It is the anterior cruciate ligament that connects the tibia, the shin bone, to the femur, the thigh bone, and is at the center of the knee. This limits the forward and rotational movements of the tibia. The knee also has a posterior cruciate ligament, which is located just behind the anterior cruciate ligament, that limits the backward motion of the tibia. These two, the anterior and posterior cruciate ligaments, together with the muscles, manage the amount of stress that is applied on the knee while walking, running, jumping, and so on. These acts in tandem with the muscles of the leg.
Proteoglycans are manufactured by chondrocytes, the major cell type in cartilage, and are very good at retaining water. Strong, healthy cartilage has a high water content and provides a virtually frictionless surface for the bones to glide against. Bathing the ends of the two articulating bones is synovial fluid. This is a thick fluid that is similar in composition to plasma, with the exception that it contains high amounts of hyaluronic acid. Hyaluronic acid makes synovial fluid very thick and slippery and helps synovial fluid contribute to the frictionless movement of the two bones against each other, as well as providing all the nutrients to nourish the cartilage. The synovial fluid is contained within a fibrous joint capsule, which is lined by the synovial membrane. Cells within the synovial membrane, called synoviocytes, manufacture hyaluronic acid and many other essential molecules and prevents hyaluronic acid from escaping the joint space. Healthy synovial fluid has very few cells. Blood is routed around the joint capsule but does not leak into the healthy joint.
So knowing that it's a compressive problem, does doing this repeatedly for 20 minutes sound like a good idea? No, it's not. It's too much pressure going up through the joints here. It's putting more pressure through these discs. You do not need that movement repeatedly.
The spinal column is also known as the vertebral. There are 26 vertebrae in the spinal column and an intervertebral disc between each. The vertebral or spinal column's function is to protect the spinal cord. The main function of the invertebral disc is to act as a shock absorber between each vertebra.